This is an assembly of gearhead motors I've assembled over the years through various sources. What's nice about gearhead motors is usually if they're not really geared up, you can put some kind of hand crank on the front of them, and usually it's just a DC motor on the back side. So that DC motor can be turned into a generator. So obviously the advantage is you're not turning these 5,000 RPMs to generate the correct voltage because it's geared up in this part. So I'll go ahead and do a demo of these and how you can use them as a impromptu generator set. Gearhead motors, when you turn them into generator sets, is all you have to do is watch which direction your hand crank turns when you connect your battery power up to it. So you don't really even need to know polarities. You just have to watch your direction of your hand crank. So, and I time that, see how many times that turns in a second or seconds. And then to charge the battery pack I got here, I counter rotate the direction it's turning now, probably just a hair faster in the opposite direction, which would be clockwise. So that should approximately match the voltage going in, but I'll be putting the voltage back into the battery. So this is the battery pack for my digital camera. And again, I don't even really need to know the voltage on this. It is 3.7 volts. And I don't really even need to know the polarity of the terminals up here, just as long as I'm keeping track of the rotation of my crank handle. We'll see how fast it turns the crank handle. So if I wanted to charge this battery, I'd turn the handle the other direction, just a hair faster than that, to charge this battery. So I don't really need to know polarities or voltages, just timing on the hand crank there. So this is the battery out of my cell phone. Again, I'll just watch the rotation and the speed. So to charge this, the way I just have it hooked up right now, I'd go slightly faster than that, counterclockwise, or I'm sorry, clockwise. Guy can never have too much fun, so I bought a number of these, and I bought these little plastic spools that actually just happen to fit on these motors. Experimented with different hand cranks designs. So yeah, for $2, basically got a generator set that I can use anywhere. Just put some wires connected up to the terminals and back there. And this one's actually already set up for a battery, so I could actually charge a 1.5 volt battery right in the back of this unit. So, but the one I made, I put some leads on it so I could actually charge other batteries outside that wouldn't fit in the D-cell size slot here. So I'll see how fast this gearhead motor turns for my camera battery. About that fast. See how fast it turns for my cell phone battery. About that fast. Again, spin it the other way, slightly faster rotation to charge the batteries. See how fast it turns for this, which should be quite a bit faster. This is at 6 volts. So, and then another gearhead motor I have. This thing is way geared down. So it's almost to the point of you can only charge low voltage batteries with it. Otherwise it'd probably bust the shaft off the front of it trying to transfer the torque back to the actual motor. This is another gearhead motor, same deal. This thing's way geared down. So you'd have to be careful that you don't overstress the shaft you put your hand crank on. So, but these gearhead motors can be had for pretty cheap. Usually shop around for them and get them for a couple bucks. But the fun is just trying to figure out a way to put a hand crank on it, put some leads on it, try to make it something that'll attach easily to a battery. Could even actually just buy regular professionally made power jacks if you know what you're powering up or want to power up. What I did here is I took a gearhead motor, mounted it in a plastic box, put a crank handle on it and a voltmeter. So what I did here is I connected my little generator set up to another gearhead motor, essentially, which also could act as a generator. But so I'll turn this, and the electrical current will go out through my wires here into this motor and turn that motor. So it's really not a mechanical linkage to the other motor. There is a huge selection of already made devices that have hand crank generators built into them. This is a radio set I have and combination flashlight. So it has the hand crank to the generator on the back side. I can turn on the radio somehow. Or I can turn on the flashlight. And then this is a kind of neat. It's kind of a reciprocating crank. It lights this flashlight. It's a little built-in generator. It's kind of curious because it actually uses a really small filamented incandescent bulb. It is an LED technology. So this thing's actually kind of vintage, but it works great. It actually puts out a lot of light. And then another, this is a little more modern. It's a hand crank LED flashlight. So if I had this stored for 20 years, potentially I should be able to just pick it up, not worry about dead batteries. Should be able to just crank it right up. So probably the smallest handheld crank thing I own. I just bought it as a novelty thing. I think I paid $3 for it at the grocery store, but it's a miniature hand crank LED light that'll fit on a keychain. Another common, this doesn't really even have a crank, there's a magnet inside that reciprocates back and forth, and that's how you generate the power for the battery. So it's kind of a weak LED, but I guess if that's all you had, you'd be happy with it. Kind of one of the more awkward ones to use, but no handles to bust off, so that's sweet. One additional hand crank flashlight / radio I'd like to add to my list is this weather ready energizer. Really ergonomically designed. It's got a really nice heavy duty solid hand crank on the backside. And either you can have a radio, FM or AM, or a hand crank flashlight. So, and usually about every 20 seconds of winding you get about 2 minutes of usable light. So you don't have to do a continuous crank to get the light going. So that should last for about 2 minutes. And then backside there's a switch. You can go to look for an AM radio or an FM radio station. Don't really want to crank it when you got the radio going because you get a lot of static. I have this universal power jack. What I'll do is I'll put in the jack that fits in for the earphone plugs in the back of this, and I'll, without breaking the machine down and trying to rewire it internally, I'll just try to tap into the earphone port here. And basically, when I crank this flashlight now, it should actually power up this motor through my set of wires and my alligator clips to the motor lead. Since my power is coming out of my earphone plug-in, I want to make sure my switch back here is turned to either FM or AM radio. And so what would power my earphones is now going to power my electric motor. So potentially you could power up a cell phone with that. Oops. So I'll go ahead and take the battery out of my cell phone here. They usually tell you on the battery what the voltage is. Just curious relative to the generator what the voltage is. So and this battery says 3.7 volts. So the ideal situation would be to charge my battery here at slightly over 3.7 volts. That's how battery chargers work. They usually charge slightly over the battery voltage. So I'll go ahead and see what the voltage is actually coming out of this earphone jack plug-in when I crank my generator set. And ideally it would be slightly over 3.7 volts to charge this cell phone battery. This is my voltmeter, so I'll go ahead and crank the handle here, see what kind of voltage is coming out of my earphone jack plug-in. So looks like I get up around 3.5 volts when I crank. Kind of that's a surges up to that. So in theory I should be able to charge this battery with this hand crank generator set out of my earphone plug-in. But obviously it'd probably be a tough way to charge a battery, but in an emergency you might be able to get out a real short phone call.